Okay, hello everyone. We're gonna start today's class. Steven told me that he may or may not be able to make it today. So, based on what's going on right now, I don't think he'll be able to make it today. So it'll just be me. And then, okay, so today we're gonna learn about functions. I'm pretty sure most of you have heard the term about what functions mean. They're essentially, a function is something where when you put in an input, you get exactly one output out. So that's essentially all a function is. So that's what we're going to start with. And then, so this is a very simple problem. It's just state whether each of the following describes a function or not. For each that is a function, describe the domain and range. So I'll just give you 2 or 3 minutes to try to do this. The domain is essentially what values you can put for the input, and the range is what values you'll get out for the output, essentially. So try this. I'll give you 2 or 3 minutes to do it. Oh yeah, and then also send in your answers to me once you're done so I know how far everyone is. Okay, that's enough time for this problem. So for the first one, no matter what month is the input, there's exactly one number that can be the output. Because for this problem, the case is that name of month and then number of days in that month in 2005. So essentially, whatever month you put in, there's only one answer that you'll get out. So therefore, it is a function. So then that's how we know that. And then if we input 30, and then for B, the thing is that if we put in a integer, for example, say we put in the number 30, we'll get multiple outputs because number 30 could be multiple months of the year. Therefore, that one's not a function because with one input you can get multiple outputs. For the function, it needs to be the other way around. You can only have one output for every input. So that's why B is not. And then for C, a positive integer. So for C, the answer is it's not a function because if you input one number, the output could be multiple numbers, and therefore it can't be that. And then also for number 4, since non-positive inputs, there are no perfect squares, that doesn't mean it's not a function, but it means that you can only put in non-positive numbers. So therefore that restricts what the domain is essentially. So then we're going to go on to the next question, which is slightly more difficult. So consider the function f of x equals 2x plus 5. So essentially what this 1 is what should go inside of this x part right here, which means that is what we put into our function here. So try these. These are pretty simple problems. So I'll give you again 5 minutes to do it. Okay, we're going to go over this problem now. So for the first one, it's f of 1. So essentially just put in 1 for x. When you do that, you get 7. Second one is -3. You put -3 in for x, you get your answer is -1. For the last one, you put 0.5 in. When you do that, you get 6. That's all there is to that problem. For the second one, if f of x equals -3, let me go back to that. So if f of x equals -3, that essentially means this function has to equal -3, which is what they do here. And then when you solve for x, you get x equals -4. And that's the value for this, because when you put in -4 for this, that's how you can get out -3. So that's your answer. And then for letter C, in terms of k, what is f of 2k? Which means you just put in 2k for x. So when you do that, you get 4k plus 5. So that's all that is. You're just taking that number, putting it in there. And that's it. On to the next problem here. This is another problem. It's slightly more difficult. There's more parts to it. I'll give you 7 or 8 minutes to do this one, and then try to send your answers in once you've figured it out. I've only gotten one answer, and so I'm going to give you guys 3 more minutes to try to solve this problem. Okay, I'm gonna explain this problem out now. So the part A is very simple. It's like the previous ones. You just put in those numbers for X, you solve your equations, you get your answers. You can take a look after class if you got them wrong, because it's probably just a small arithmetic error. And then for part B, are there any values of X that do not produce a value for f of X? The only one would be -5, and the reason for that is that it makes the denominator 0, and if the denominator 0, it's undefined. So that's the only one that will do that. And then on to part C, we try to find the range. So find X such that f of X equals 3. Is there a value of X such that f of X equals 2? So we put 3 in, and then if we solve this whole problem out, we get X equals -18. So we know 3 is in the range of f. And then we can, and then that's essentially how you do that problem. And testing each and every number to see if it's in the range is impossible. So you can essentially see that by looking at this, you can tell that apart from -5, everything else will be in range, essentially. So that's how you do that. And then on to the next problem. Functions need not only have one input. So in these problems, there's 2 inputs, and this one there's 3. So try to solve these, and then part C is a little tougher. You have to explain why the quadratic formula is not a valid function. So I'll give you guys 8 minutes on this problem to try to solve it. Okay, I'm going to explain this question out now. So for the first one, just put in 2, 3. When you do that and you solve the equation, you get 13. Part B is a little more complicated. So what we need to do here is we need to plug in this value for x and z, and then plug in a for y. And when we do this, we get this whole equation right here. And then we multiply everything through and then add like terms, and then we end up with 3a minus 54. Then we can just make this equal 15 since the question asks for when our answer is 15. And when we do that, a becomes 23. Part C, there's not any math to it, but essentially the way this works is if you take a look at this equation, there's a plus or minus, which means unless this part equals 0, you're almost always going to get two solutions for any inputs you put, which means this is almost very rarely a function. It will only be a function if this part equals b squared minus 4ac equals 0, because plus or minus 0 is just 0. But if this equals anything else, you'll have a plus something or a minus something, which means you have two outputs for every one input, which makes it not a function. So now we're going to move on to something slightly different. Here, we're actually going to be combining two different functions together, f of x and g of x with different inputs. So these are all pretty just simple math. So I'll give you guys 6 minutes to do these problems. Okay, we're gonna explain this problem out now. So for part A, let me find the problem very quickly. Yeah, so for problem one of this, hold on, let me find it. Okay, yeah, I got it. So for the first part, you have f of 3 plus g of 3, so you just plug in those values and then into those respective functions and add them together, you get 8. Same thing with this one, same with this one. All three of them are very similar in that respect. There's not much else to them. For part B, it's let s of x equal f of x plus g of x. And then if you add these two together, you can combine the like terms, you get 5x minus 7, and then that's a function because for every number you put in, you only get one answer out. For part C, if you multiply them through, the answer should be negative 33 and 52. And then if you multiply these together, it is still a function because even though multiple inputs can give you the same output in a quadratic, but every single input will only have one specific output though. So that's why it's a function. And then the main takeaway from this problem is that if f and g are both functions, if there are these two functions, if you add them together, multiply them, subtract them, they're always going to be functions, even if you do any of those operations. And if you divide them, they'll also be functions as long as the denominator does not equal 0. So that's just a very important takeaway from this class, is that you can manipulate these, and they will always be functions, with the one exception being if you divide by g and if g is 0. So here's another problem very similar to the last one. I'll give you guys 5 minutes on this problem again. Okay, we're going to go over this problem now. So for this one, the first one says find the domain for f of x, which is just square root of x. And for that one, the domain is what inputs you can put in. Since it's a square root, any positive number, 0 and higher, will work for that one. For part B, it's g of x, which is square root of x squared minus x minus 6. So essentially, whenever that is greater than or equal to 0 is when that'll work. So you take this, you factor it out, and then you can figure out that when x is greater than 3 or x is less than or equal to -2, there will always be positive, and then therefore that's the domain for that one. And then for 3, what is the domain? You just add both of the functions together, and then what you figure out is what you actually realize is that the domain is just the most restrictive version of these two. So it has to be positive for this one, which means this solution doesn't work, and so this has to be greater than or equal to 3. So that just means the only domain is greater than or equal to 3 because that's the only thing that'll satisfy both domains. And for this part, you put it over like this, and then essentially what you do is you solve it out, and then we put 3 to D, and then essentially when we do this, we can figure out when we can't divide by 0, and then that is when we can't equal our domain. So actually, we're running a little behind, so I'm not going to explain every problem tonight. I'll try to be as fast as possible. So for this problem, I'll give you 5 minutes again to. Okay, we're going to go over this problem. So essentially what you do with these is when you have g of 2, like this f of g of 2, you do the g of 2 part first. So you put in this 2 for the x, you get an answer out, and then that answer is what you put into this x here. So for the first one, and put g of 2, we get -3. So we know g of 2 is -3. So f of g of 2 would just be f of -3. When we do that, we get our answer. It's the same with part B. But notice how all the only difference was that these were inverted. However, the answers are not the same, if you realize. So that's something you need to be aware of. And then for this one, the function definition just tells us that if you multiply it and then it says put g of x into the function, so the result is 2 times g of x minus 6. So that's all that's going on in that problem. So here's another problem that's very similar to that one. I'll give you a little longer. I'll give you guys 6 or 7 minutes. Okay, I think that's enough time for this problem, but since we are actually running a little low on time, the explanation is here. You guys can read this later on when I send the PowerPoint out, but we're going to move on to this one. This is a lot much harder problem, so I want to take more time explaining this one. So try your best on it. I'll give you guys 10 minutes. It's a pretty difficult one, but after that, I'm going to explain it to you. Okay, I'm going to explain this problem out now. So essentially, when we do our f of 3, well, f of 3 equals 7, f of 6 equals 16, f of 10 equals 28. That's just simple math. And then when we put those in, what you realize is that the answers you get out were the same as the inputs you put in. Yeah, I don't know if you guys realize that. So what this means is that g of f of x equals x. So essentially, what this means is that the function g is undoing everything f does. So in other words, if we put in a number for f, it'll get us an answer, and we put that answer into g, it'll get us back to what the original thing was. So that's essentially what this is. And these are what we call inverse functions. And it's the same thing again here. This is just talking about the previous part again, and that it'll always do that same thing backwards. So that's the main takeaway from this problem. And the easiest way to find inverse functions is if you have this. This is essentially y equals 3x minus 2. Switch the x and the y around. So make it x equals 3y minus 2 and then solve for y. And when you do that, you can figure out what the inverse function is. Because in this case, it would be y equals 3x minus 2. If you add 2, it would be y plus 2 equals 3x. And if you divide by 3, it would be x plus 2 over 3 equals y. And that's essentially what this function is here. So that's how you can figure out inverse functions. And now we're gonna keep moving on with some problem solving problems. So if f of x minus 3 equals 9x squared plus 2, what is f of 5? I'll give you guys, again, 5 minutes, 5 to 6 minutes on this problem, and then I'll go over it. Okay, I'm gonna explain this problem out now. So for this one, all we do is you can easiest way to find the correct x is that we know it's f of 5. So we set f of x minus 3 equal to f of 5. And then essentially what we realize is that x equals 8. So because f8 minus 3 will be f of 5. So we know f equals 8, which means x is 8. So we use 8, we put it in here, we square it, multiply by 9, add 2, we get 578. So that's one way to do it. Another way to do it is to take into proper expression. So you do f of z, you do z equals x minus 3, and then you do x equals z plus 3. So you do z plus 3 minus 3, and you can put the z plus 3 into the equation. And if you solve it that way, you'll also get 578. This is a lot more complicated. This is a much simpler way, but for those of you who did it this way, the solution's here. We only have 3 more problems left, so you guys are almost done. So this is another problem very similar. So this one is a function that's defined for all positive integers, has this property. F of m plus f of n equals f of m times n. If m and n are positive integers. So if f of 2 equals 7, f of 3 equals 10, we calculate f of 12. I'll give you guys 7 minutes for this problem. Okay, so we're going to go over this problem now. So first we start just doing some trial and error with the parts they gave us. So what we see here is that f of 6 equals f of 2 plus f of 3, that equals 17. And since we want f of 12, we just do 12 equals 2 times 6, and we know that we know both f of 2 and f of 6, so we can find f of 12. So essentially, f of 12 is just f of 2 plus f of 6, which is 7 plus 17 equals 24. So that's all there was to that problem. And then we only have two more problems left. But these are more difficult. So they're pretty short, but they're very difficult problems. So for this problem, I'll give you guys 8 minutes to try and figure it out. Send me your answers once you're done, so I know when I can move on to the next problem. Okay, I think that's enough time for this problem. So this problem is actually relatively simple if you could figure it out. The patterns are kind of tough to understand. So this spade is essentially just a placeholder essentially. So x something y is x plus y, x minus y. So 4 is x in this case and 5 is y. So when you plug those in, you get something. And then 3 of that. So then 3 is x, and then whatever answer you got for this part here is what becomes your y. So that's how, because with this we get -9, so then we get 3 spade -9, and then we get -72 as our answer. So yeah, that's how that works. And then this is the very last problem for tonight. So I'll give you rest of the time. So I'll give you guys 7 minutes to do this problem, and then we'll go over the answers, and that'll be the end of class. Okay, we're going to go over this problem right here. So this again, so we have to solve this x pound 3 equals 37. So first we write the equation out, and then this is essentially just equals x times 3 minus x plus 3 minus 8 is 2x plus 5. And the way we know that is that x and 3 are a and b essentially in this. So we put those in, we get 2x minus 5. And since we know this equals 37, we put 2x minus 5 equals 37. And then when we solve that out, we'll get x equals 21. That's how we know it. And so the thing with functions is that sometimes they use these really weird symbols, but they don't mean anything. As long as you can get over the fact that they're weird symbols and you can understand the logic behind them, then you'll have no difficulties whatsoever solving these problems. So that's it for today. Just as I told you again, there are office hours on Saturday, so in case any of you have questions, please come to these. These are their timings, and you'll see them again in the email when I send out this PowerPoint. But that's it today. Thank you all for coming, and